the search for the ideal connection. And that's a big differentiator in the implant industry. Implant Direct offers a variety of platforms. We have the lead-in bevel, which is on the legacy BioHorizons, Screwvent, MIS, most of the Israeli clones. Every country, in fact, makes a copy of this Screwvent connection. In Europe alone last year, 3 new companies started with this connection. Then the trilobe, the internal octagon from Straumann, but we've added a square so that you can engage it with the tool to screw it in. So you don't need a 2-piece handle to stabilize when you're removing the fixture mount, as you do with Straumann. And then we have an external bevel, which acts like a ferrule effect and directs the forces in. This was the first one that Implant Direct made. I have a patent on a trilobe. I got around Nobel's patent by putting double grooves in. Their patent calls for these 3 micro grooves, a cylindrical unthreaded section, and then internal thread. So I just extended the grooves all the way down to take full advantage of the length for increased stability. Now our fixture mounts for the Re-Plus and Reactive engage the full depth of those grooves for increased stability, but all of our abutments only engage the top ones, so they're compatible with Nobel. Nobel has come up with 2 new implants. This one is their platform shifting. So all they did is step down, use one smaller size platform. They use the 3.5 platform on the 4.3. They use the 4.3 platform on the 5. And it can get very confusing with their color coding because the same abutments are used. Then they also put the NobelActive conical connection on a Nobel replace implant. So they've just added 2 more implants that really don't add anything to the clinical success of the case, just to meet the demand of different dentists. Here is our interactive implant with the micro grooves. Here is a 3D picture. You see the 3 cutting grooves, the round apex, the long cutting grooves going 2/3 the height up, the conical connection, color coded to match Nobel's colors, and the micro grooves. And it'll be available in 4 diameters, 3.3 and 3.7, which will have the same platform, 4.3 and 5. NobelActive requires that you take X-rays to see if the abutment is seated, because it has this long bevel, and just looking at the implant you can't tell if the bevel is all the way seated. On their transfers they put a groove there now so that you can see it, but they can't put that groove on the abutment. So if the screw engages before the hex is seated, you don't get this seated, and your transfers won't work, and your restorations won't fit. We've tried to solve that problem with our interactive abutments by making the hex longer and the bevel shorter, so you can clearly see if it's not seated, the hex will be above the crest. We still have the same angle on the bevel so that this will fit Nobel's implants and ours, but it'll be easier to identify whether it's seated. We also added a little extension here that fits down into this part to straighten it up, and we put internal threads inside the abutment so that you should really seat the abutment first by rotating and feeling that it's seated, and then tighten your screw, and then the screw will come out of the abutment and into the implant. So that's how we've tried to solve that problem. Again, with continued design, quote, innovations to differentiate products, you have Dentsply has now bought Astra. I think they paid over $1 billion for Astra. They also have the Ankylos product that they bought. And Astra, to differentiate their product, has come up with a profile top on the implant. Well, Nobel used to have the Nobel Perfect with the double profile. It's now obsolete. You can't even buy it. It was brought no clinical advantages and had complications, so it's off the market. You can still buy abutments for it. So Astra has now got half of a Nobel perfect implants. This is the Astra implants. They're generally straight implants with micro grooves, nothing spectacular. They do have one version with a flared neck, and that's the one that they've put the slope top on. Now, when you have this long conical connection and a flared neck with very thin walls, guess what happens when you overload the implant? Tighten down this abutment wedge, forces go outward, and what happened here is the wall of the implant broke, and there it is floating right there. And so much for microthreads stopping bone loss. You can see how thin that wall is on the cracked implant. That was given to me by a dentist. Another thing to look at is the abutments and how much torque does a company recommend you tighten the screw. This is a very critical matter. NobelActive came out with a 3mm implant, but they warn you do not tighten beyond 15 Newton centimeters. They got a little screw in that implant, and it could strip or fracture. They're angled abutments, angled screw receiving abutments for teeth in a day procedures, also 15 Newton centimeters. Astra has 15, 25, 20. Who wants to figure out which torque you should apply depending on which abutment you bought? All of ours are 30 Newton centimeters. Apply the force and the abutment will stay in place. Now, this is Dentsply's Ankylos implant versus Dentsply's Astra profile platform. They now are selling competing implants with competing theories. The Ankylos, which is a Morris taper, that means a tap-in press-fit connection, requires a long run to the abutment till the abutment gets to the height of contour. And as a result, you have to drop the implant below the crest of the bone just in order to get the height of contour of the abutment below the crest. So this implant advocates positioning below the crest of the bone. Now Astra comes along, now owned by Dentsply, with a profile top implant, and it teaches something different. Here's the Ankylos below the crest of the ridge, and this, I just simulated this to show what it would look like if you added 2 more millimeters to the implant. You'd get a better emergence profile. You'd preserve contact with probably the best quality bone in the ridge right at the crest. So they're not saving bone, reducing bone loss. They're giving up on all this good bone contact. Sometimes you need to create a countersink in the crest just to get the abutment seated. And another case with Ankylos, again, look at how far below the crest of the ridge that is. A better solution would be to add 2 millimeters onto the implant and take advantage of all that good contact and then have a normal emergence profile. So Astra justifies this profile implant this way. They say, well, you'll get a scalped ridge sometimes where some of the implant's exposed on the labial. I say don't worry about it. What does it matter whether the first millimeter or 2 against the soft tissue is the surface of the implant or the surface of the abutment? It doesn't really matter. Now you can avoid it by flattening the ridge using smaller implants. One of the reasons you get this scalloping is this implant flares out. So you need to make a bigger hole to accommodate that implant. And so they say, well, you know, it gets exposed and you don't want to put the implant farther in the bone to be level, because then you'll have this bone projecting above the implant, which is exactly what Ankylos tells you you should do. That's the same company telling you to drop the implant below the crest. So that's the justification for a contoured implant innovation. The solution would be leave the labial exposed, use a narrower implant so you didn't scallop, reduce the crest of the ridge on the lingual if you didn't want it projecting above the implant. We have crestal bone drills that when you turn it forward, it widens the crest, which is the densest bone, to the diameter of the implant. And when you turn it reverse, it plateaus and flattens the ridge. So we have drills just to do that procedure, flatten it. But if you didn't flatten it, what does it matter? So you'll have bone growing over that bevel. Since the abutment is fitting on the internal conical connection, you wouldn't want bone growing over it if the abutment was hitting the outer periphery. You wouldn't be able to seat the abutment. So this is the justification for this contoured profile implant, and I think it really brings nothing to the table, just adds complications. I've seen cases where they use that in the lower posterior, where if the ridge dips down, they'll use this profile, rotate it so the lower part is to the mesial to follow the profile. I guess they're worried about molar papilla aesthetics, which is something that I never really worried about in my practice.